Okay, I'd just like to apologize in advance. I've been recording my videos in 4K, but the output has not actually been in 4K. So when I've uploaded, the quality has not been as good as I'd like. I've updated my settings. Unfortunately, I didn't realize that I hadn't updated my encoder settings, so there are some graphical issues throughout this video. I have remedied them, but unfortunately, I cannot fix what's already been recorded. So you'll see at the end it does improve, but unfortunately, I apologize again throughout the video. The quality does drop in some places. Welcome back to another video on motorcycle engineering and design. In this video, I draw up a concept of a fabricated tubular swing arm. There will be one non-tubular part, which will be the swing arm end blocks. Now these could be fabricated parts with plates welded together, but in this concept it's going to be a CNC machined part. You'll see in some of my past videos some of the methods I'll be using here, such as using joints and joint origins to move parts into position, and also for creating the notches in the coping of the tubes. You'll see that I start with using the joint origin method for positioning my part. And I'm going to start with breaking the swing arm down into a number of pieces, starting with the right hand end block. Now I know I want the internal width of the swing arm to be 220 millimeters at the rear, so I create the joint origin 110 mm from the mid plane. Then I move the new component to this joint origin using the joint feature. So for some components I like to start with laying down some lines and then converting those to construction lines. It becomes useful whenever you want to use the symmetry feature or offsetting features from the construction line. So it's my intention for this project to make the frame and swing arm as easy to manufacture as possible, to the extent that you could potentially manufacture it in your own garage. At least with the exception for a couple of CNC parts. So as you can see, I'm just using simple shapes here with an extruded block and then extrude cutting a triangular shape through that block to create this kind of taper at the end. So here's another case for using construction lines in your sketches. So this construction line is from center to center of the slot ends. So just by adjusting the length of this, you'll essentially adjust the length of the slot, or the range of chain adjustment that you can make. And this is extruded through the body to remove material. So the pocket and the edge of the taper actually comes in line, which means that if we try to add a round on that edge, it's gonna cause problems. So just by extending this pocket a bit further, we can avoid those problems. Now I want to create some bosses to fix my tubes to on this end block, but I also want them to be an angle, so I'm just adding this extra block of material at the end here. So here are the bosses. We have a larger diameter boss at the bottom at the seat, and then a smaller diameter boss which extrudes into the tube. Now ideally I should make this a little bit longer than I have at this moment. But essentially you'll have the weld sit over this boss, and that will help to reinforce and stiffen the bottom end of the tube, and then we can have a good surface, a good area for welding. Now to quickly move this along, we can just use the mirror feature here and then change that to component and mirror it across the center plane. Now these two parts are not going to be identical, but up until now they can be. Later on as they're developed, they'll have additional features added on. For example, the right hand has the rear brake to consider. So to make it easier to position the tube, I'm just going to use the joint origin at the base of this boss, and then we can just use the joint feature to move the tube directly to this position. So I start with creating the new component, the lower tube, and then using the joint to move it into position. In programs like Creo, I would be using coordinate systems. I'd be placing a coordinate system in a position relative to another coordinate system. In this case, it would be relative to the coordinate system of this component. because that's the relationship that I want it to maintain. So we want to keep this tube as simple as possible, so we keep it all on the same plane. And when we have some bend radiuses, we try to keep those to be consistent as well. Generally, the less features or the less variation of features, the cheaper a component's going to be to produce. So here we draw the profile of the tube, and then we can sweep that down this curved profile that we've drawn here. Then to very quickly speed things up, we can mirror this across the mid-plane as well. Now these are currently still surfaces. I do change that later on just by going into that sketch profile that's being swept and adding in the internal diameter. So I use the same method as before, using the joint origin and the joint feature to move the new component to the angled boss. And then I've gone into that component to sketch out the profile that I want to sweep the tube around. Now it's not taken long, but I think we've already got something that's starting to resemble a swing arm. So of course I need to add some more tubes for stiffening and reinforcing this swing arm as it is, but there are also some other considerations that we'll take into account later on, but let's consider this now as well. On the left side we are going to have the chain passing through, so we need to make sure we have clearance all the way through and we don't obstruct the path. So repeating the same methods as before, we positioned and modelled a new cross brace between the two lower tubes. Now it's always nice to take a step back and take a look at your progress. It also is useful to checking the proportions. In this case I think the tubes are looking a little bit skinny and also a little bit too far back from the frame. Potentially need to pull those a bit further forward later on. So now I'll just start positioning all of the tubes for reinforcement. One useful thing for joint origins is you can use one as a reference for a new joint origin and then offset it like I have done here. So if I was going to be making 2D drawings for these parts, I'd probably be trying to rotate the whole coordinate system of the part here instead of drawing a sketch at an angle, because it's just easier to do the drawings when your tube is in line with one of the axes of the coordinate system. Now I'm looking at adding in the longer tubes that are going to connect to the front end of the swing arm back to the upper tube. And this time I'm going to create that with the 3D sketch. 3D sketch, in order to do that you just create a normal sketch, and then in the window on the right you can see at the bottom it says 3D sketch. With that ticked, whenever you start a new line you can then click on whichever plane you want to be drawing that new line on. Okay, so now we have the right hand tube. I don't really like the position this is in right now, but I know that I'm going to come back and redo the swing arm, so I'm not going to worry about it right now. There's a few more things I want to add in here. So one of them is going to be coping the tubes and then later adding the welds. There is the lower mount point for the rear suspension unit, and currently I'm just using some folded plate metal here. So I'll also have to consider the rocker linkage in this assembly here as well. Now if you're interested to learn more about the rear suspension unit, the rocker linkage and dynamics all relating to this, then let me know in the comment section down below and I'll go over it in as much detail as I can in another video. So I decided I didn't like this tube being the full length of the swing arm, so I've cut out the middle section and added in a new brace tube towards the front. Now I actually don't like the position of these tubes as they are because it's just not going to be nice for welding. So just to try and make this look a little bit more complete, I modded in some adjuster blocks, and these are not going to be identical mirrored parts. So there is a point in the process where the body is mirrored across to the left hand side, and then each one is then modeled separately. So just to bust a myth here, there is no issue with installing your spindle from the right hand side of the bike. It's just usually been the left hand side because there's less obstructions on this side. The torque setting is far more than anything you'd expect from the wheel, and then also you have the things like the cotter pins to help keep that in place as well. And lastly, I came in to repeat the process of adding notches or coping to these tubes. As I've shown in a previous video, we can use a surface to split the face of a component, and then we can use the push and pull on that face to remove the material. In this case, I've used this split face on both the external and internal surfaces, and then repeat the push-pull on both. So this is the initial concept. I've managed to keep clearance on the left-hand side for the chain, but there's still a number of features we still need to add in going forward. Things for the rear brake caliper, the rear hugger, and the chain guard, various hoses and cables. In general though, I still think it's really too skinny, so I do need to thicken up these tubes. So from now, I think I'm going to go ahead and make some changes to this swing arm. So I've thickened up the tubes, and I definitely feel that this is a bit more substantial, definitely better than it was before. This is definitely not a final concept, it's definitely still a work in progress. There are a lot of extra features we need to take into consideration with coming up with the final design, and we can start working more of that in as more of the bike is developed. And one of those parts is the rear hugger, so I've just mocked up this rough surface just to see how it might look. I definitely want to make some more adjustments to the swing arm here. If you have stuck around to the very end of the video, just want to say thank you very much. I hope it's been interesting, I hope you've learned something, and I hope you stick around for the next video.